Hi students, as you all know that we have done the chapter number 2 solution. Now today we are going to discuss about chapter number 3 and the name of the chapter is electrochemistry. I hope you all have done electrochemistry in class 11 where you have done the process called redox reactions. In redox reaction we have seen oxidation and reduction takes place simultaneously. So this is the advanced version of redox reactions. Here we will study about few new concepts. Before starting, we must know what is a redox reaction. We know redox reactions are those reactions in which oxidation and reduction takes place simultaneously. So redox reactions in which oxidation means loss of electrons and reduction means gain of electrons takes place simultaneously. So both the processes takes place simultaneously called redox reaction. Why we are dealing with redox reaction now? Because when we proceed further in electrochemistry, we will have to use oxidation and reduction. So redox reactions are those in which oxidation as well as reduction takes place simultaneously. It means one substance gets oxidized whereas the other it gets reduced. Now, what is electrochemistry? Let's see the definition of electrochemistry. As it is clear from the name, electrochemistry is a combination of two words. Electro means electric charge, or we say current, and chemistry. So electrochemistry is a branch of chemistry which deals with conversion of chemical energy into electrical energy. So it is we say electrochemistry. It is a branch of chemistry which deals with production of electricity or relation between electricity with the redox reactions. So we can easily say electrochemistry, branch of chemistry which deals with relationship between electric energy and chemical energy in redox reaction. This is what we call electrochemistry. Now, we all know what is electrolysis. Let us discuss about electrolysis. Electrolysis is a process of dissociation of electrolyte into its ions on passes of electricity. So, electrolyte is a substance which dissociates into ion, and the process of separation of ions is called electrolysis. Keep in mind, electrolysis process takes place in the presence of electric current. Let us take a simple example. We have taken an electrolyte. This is an electrolytic cell. Here we use a battery. Here we are using aqueous solution of NaCl. It has been found that when electric current is passed through these two electrodes which are inserted or dipped in an aqueous solution of NaCl, when current passes through it, NaCl it dissociates into ions. So NaCl When it dissociates into ions, it forms sodium ions as well as chloride ions. This process of dissociation of an electrolyte into its ions is called electrolysis process. And we have to keep in mind here these two electrodes, one is called cathode and other is called anode. The negative plate is known as cathode, whereas the positive plate is called anode. So there are two terminals, we say two electrodes. These are electrodes. The rods which are made up of metal called electrodes. So cathode is the negative plate and anode is a positive plate. When electricity is passed through NaCl solution, it dissociates into ions. Hence, the ions, they move towards opposite electrodes. It means the sodium ions, which carries positive charge, they get drifted towards negative cathode, whereas chloride ions, which carry negative charge, they get drifted towards the positive electrode. That means they get drifted towards anode. This is called electrolysis, and the rods here we use are called electrodes. Now here we have to keep one thing again in mind, that oxidation always takes place at anode, whereas at cathode reduction takes place. In electrolysis, there are two types of changes that takes place. One is known as primary change and second is called secondary change. Primary changes are simply defined as those changes in which the ions reaches to their respective electrodes get converted into neutral species. Like in this case, when sodium, it moved towards cathode, gain one electron, get converted into sodium atom. This is known as a primary change. Keep in mind, primary changes are those in which the ions move towards their respective electrodes and get converted into neutral species. Whereas secondary changes are those which are formed due to the primary changes. In some cases, there are primary changes, but the product which we are expecting is slightly different from the product which actually we get. That change is known as secondary changes. So we have two types of changes that takes place during electrolysis: primary changes as well as secondary changes. Now let us discuss the electrolysis of molten lead bromide. We know that lead bromide PbBr2, when it dissociates, it forms lead ions plus it forms bromide ions. So when the electrolysis process is carried out, the Pb2 positive ion, that is lead ions, since they carry positive charge, they get drifted towards cathode, and after reaching at cathode, they gain 2 electrons from the cathode. As we know, cathode is a negative plate. So lead, after gaining 2 electrons, get converted to lead, neutral molecule. Here reduction takes place, and this is called a primary change, because the lead here we obtain is as it is in molten state. Primary change because of neutralization of ion. Now the reaction which takes place at anode, bromide ions, since they are negatively charged, they move towards the positive plate and they move towards anode, lose 1 electron, get converted into bromine atom, that is a free radical. This is again oxidation. Why oxidation? Because bromine is losing electron, and loss of electron is called oxidation. So bromine has lost one electron, get converted to bromide free radical, oxidation takes place, change is called primary change. Now, two free radicals of bromine, they combine with each other because free radicals are highly unstable. So bromine free radical combined with another bromine free radicals to form Br2, that is bromine molecule. Since this change takes place after the primary change, that is why this is called a secondary change. It means during the electrolysis of molten lead bromide, we get molten lead on cathode and we get bromine gas on anode. So cathode gives molten lead, anode gives bromine gas. So this is the concept of primary and secondary changes. Let us discuss another example. Let us discuss the electrolysis of NaCl, that is molten sodium chloride. Keep in mind, molten sodium chloride does not contain water molecules. It's the same way. NaCl, when it dissociates, it forms sodium ion and it forms chloride ions. The sodium ions, since they carry positive charge, they move towards cathode, gain electron, get neutralized. We get molten sodium, reduction, primary change. Similarly, chlorine, that is chloride ion, they move towards anode, lose electron. Keep in mind, minus shows loss of electrons. Get converted to chloride, that is a free radical, Cl dot, free radical. Oxidation, and this is a primary change. Since Cl, free radical, is unstable, so Cl free radical combined with another chloride free radical form chlorine gas. The overall reaction can be written as 2NaCl gives 2Na, Na is obtained at cathode and chlorine gas will be obtained at anode. Now let us discuss a very important concept. The concept is when we do the electrolysis of aqueous sodium hydroxide solution. Keep in mind aqueous. Aqueous means water. So when we take HCl and dissolve HCl in water and we pass the electricity through it, or we carry out the electrolysis process, you will be quite surprised to see that instead of getting sodium, we get hydrogen at cathode and we get chlorine gas at anode. Now the question arises, why we are getting hydrogen? Why we are not getting sodium? What happens to sodium? Now, if you see here, when we pass the electricity through the aqueous solution of NaCl, both NaCl as well as water, they get ionized. NaCl, when it gets ionized, it forms sodium ion as well as chloride ions. Whereas water, it also dissociates into ions, gives hydrogen ion as well as OH negative ions. You can see here there are two positively charged cations and two negatively charged anions. The positively charged cations are Na positive and H positive. Now both these positively charged ions, they get drifted towards cathode which carries negative charge. So while they are moving from their respective or moving towards their respective electrodes, the discharge potential of hydrogen is lower than that of sodium. It means the hydrogen ion did get discharged easily as compared to the sodium ions. So hydrogen, because of small size, they move faster. They reaches at cathode, gain the electrons, get converted into hydrogen free radical. Hence, the process is a reduction called primary change. This hydrogen free radical combined with another hydrogen free radical to form hydrogen gas. What about sodium ions? The sodium ions, they remain in the aqueous solution moving. They are not at rest. They keep on moving. So, when we do the electrolysis of aqueous NaCl, instead of getting sodium, we are getting hydrogen at cathode. Now, what about the other? What about the reactions occurring at anode? Now, there are two negatively charged ions, Cl negative and OH negative ions. Again, the discharge potential of Cl negative is lower than that of OH negative ions. It means chloride ion can easily donate electrons as compared to hydroxyl ions. So, chlorine, that is chloride ion, reaches anode, release electron, get converted to chlorine free radical, which is where oxidation takes place, and change is called primary change. And two chloride free radical form chlorine gas called secondary change. What about hydroxyl ions? Again, the hydroxyl ions are free, they are moving in the aqueous solution. So we have to keep one thing in mind. Whenever primary or chemical or secondary changes takes place, that ion which has lower discharge potential, it gets discharged easily. So is the reason in this case. That is why we are not getting sodium. We are getting hydrogen gas as well as chlorine gas during the electrolysis of aqueous NaCl solution. Now let us see the last example, that is electrolysis of aqueous copper sulfate by using inert electrodes like platinum. Now again in the same way, it's an aqueous solution. Copper sulfate dissociate, it forms copper ions as well as sulfate ions. Similarly, water, it also gets ionized, form hydrogen ion and hydroxyl ions. Now, the reaction at cathode, both copper ions as well as the positive ions, they both move towards cathode to gain electron to get converted into neutral species. Since as we have done in the previous part also, that substance which has lower reduction potential get reduced easily. In this case, copper has lower reduction potential, or we say discharge potential. Since the discharge potential of copper is less than that of hydrogen ion, hence copper ion, they reaches the cathode, gain 2 electrons, get converted to copper, primary change, reduction, because copper has gained the electrons. Whereas at anode, both hydroxyl ions as well as sulfate ions move towards anode. Since discharge potential of hydroxide ions is lower than that of sulfate, we get 4OH on the anode. Hence, oxidation takes place. Change is known as primary change. Then 4OH, they combine with each other, form 2 molecules of water and release oxygen gas. It means during the electrolysis of aqueous copper sulfate, we will get copper at cathode and we get oxygen gas at anode. These electron potential, they are given in your books. Just go through the table where they have given the discharge potentials. Keep in mind that substance or that ion which has lower discharge potential get easily converted into neutral species. They reaches to their respective electrodes easily get neutralized. This is the basic of the electrochemistry. Just revise these concepts. Tomorrow we will discuss new topic, that is Faraday's laws. Thank you.